Okay, remember this is the new 9 weeks. You're still being motivated. If you need to remember your goal, look at the beginning of your notebook. I hope that you are still striving for A's this 9 weeks. I'll accept C's, but I want A's, guys. There will be a quiz tomorrow. We're still doing the solving inequalities. As you can see, it is a multi-step inequalities, what I was wanting to look at today. And we're going to go over this a little bit more tomorrow and do an activity with partners in class tomorrow. But I want to give you the meat of the lesson today, so I hope that you will watch this video and take notes in your notebook. I will try to be quick about it so it's not drawing it all out and being boring. So the problem says, Thespian members are selling shirts for $7.50 to raise money for costumes. The goal is to sell $500 by Friday. The figure below shows how much they have raised as of yesterday. What is the minimum number of shirts they must sell in order to reach their goal? So when I'm thinking about this problem, there's a couple things that I think about. I know that we've got to add some money together, and then we want that to be either more than $500, the goal was $500, so we know we want it to be equal to, or it'd be even better if it was more than our goal. You know, it's great if you're doing a fundraiser to go above and beyond. It'd be amazing if they raised $1,000. So far, I know that they've raised the $337.50. And I know that each shirt they sell is $7.50. So if I wanted to total how much money I had made from selling a certain number of shirts for $7.50 each, I could represent that by saying $7.50 times the number of shirts. I'm going to define my variable here. X equals number of shirts. And I forgot my F, one of. Number of shirts. So now the goal is, just like in an equation, I want to get x by itself. So the first thing I do is look and see, are there any like terms I can combine? Well, I've got this 337.50 and 500. They neither one have a variable. So I know that I want to get them together on the other side of the equal sign. So the way to get rid of 337 is to subtract it. The property of equality tells me, subtraction property of equality, whatever I do to one side, I must also do to the other. So I know I've got $7.50 times the number of shirts. This is going to be 0. 500 subtract 337.50 would be for sure 50 cents. I'm going to borrow. So then that's $162.50. So now to get x by itself, it's being multiplied by this 750. I know if I divide by 750, that becomes 1. Anytime I have the same thing on top and bottom, it is 1. 1 times x is x. Properties of equality tell me if I divide one side by 750, I've got to divide the other side by 750. And I believe, just remembering from doing this earlier, that it was like 21.6. Well, we can't have 21.6 shirts. And we know that we want it to be more than or equal to 21.6. So they must sell at least 22 shirts. If they sell more than 22 shirts, then that's awesome. They're going to make more than their goal. So selling 22 shirts will get them to their goal. If they sell more than that, it will be above their goal. Okay, so let's try this one. What are the solutions of 9 plus 4t is greater tan 21? If you want to do circles and squares, that's great. I see that there's a 9 here. I want to get rid of it. How do I get rid of 9? I subtract 9. Property of equality tells me whatever I do to one side, I must do to the other. So I've got 4t is greater than 21 minus 9 would be 12. At this point, I want to get t by itself. Property of equality, once again, tells me whatever I do to one side, I got to do to the other. But I know to divide by 4, because 4 divided by 4 is 1. 1 times t is t. So t is greater than or equal to 3. And if I wanted to graph this, think back to how we would graph it. There's more to the sign, so there's going to be more to the circle. I'm saying that 3 is a solution, and everything bigger than 3. So this is pointing towards 4, 5, any of those. Is 4 greater than 3? Yes. Is 3 greater than or equal to 3? Yes, it is equal to. So that's why we have the filled in circle there. Okay, in a community garden, you want a fence in a vegetable garden that is adjacent. Adjacent means it's joining, it's touching, it's right alongside your friend's garden. You have at most 42 feet of fence. So what are the possible lengths of your garden? So this problem requires you to think a little. I want you to pause the video and try to set this problem up and see what you would do. After you've paused it, then hit play and check your answer. So we know that we're building the garden right here, and it tells me in the problem that it is 12 feet. This is 12 feet. Well, if it's a rectangular garden, then we know that this side over here is also going to be 12 feet. And we also know that whatever this width is, or this length, that this length is going to be the same. So if I let it be L, then there's going to be two of them. So thinking about the perimeter, we know that if we add all of the sides together, that tells me how much fencing I'm going to need. So at this point, I've got 12 plus 12 plus the L on top and the L on the bottom makes 2 L's. And that has to be either less than 42 feet of fencing, or it could be equal to our 42 feet of fencing, because it says we have at most 42 feet of fence. So I can go ahead and combine my like terms here. 12 plus 12 is 24. So 24 plus 2L has to be less than or equal to 42. So at this point, I want to subtract 24 from both sides. Okay, 42 minus 24 is, let's see here, that would be 18, I believe. So 2L must be less than or equal to 18. Okay, so we're still trying to find the length. So I'm going to divide both sides by 2. 2 divided by 2 we know is 1. 1 times L is L. So my length must be less than or equal to 9 feet. Let's double check myself and see if I did this right. So 12 and 12 is 24. 24 plus 18. 8 and 4 is 12. So yes, 42 feet of fencing. So that means that we could make it be 9 feet wide, or let's say we decide we don't want a garden that big. We don't have to make it that big. That's just the biggest that we could make it with the amount of fencing that we had. So here's a problem. You want to make a rectangular banner that's 18 feet long. You have no more than 49 feet of trim for the banner. What are the possible widths of the banner? So this is another perimeter kind of problem. So I want you to pause it and try this on your own. Okay, so I've set the problem up for you. You can go ahead and combine your like terms. Then you know to subtract 36 from both sides and then divide by 2. So once I do that, we know that x is less than or equal to 6.5. So our banner could be 6.5 feet wide, or it could be smaller than that if we don't want to spend that much of our material on making it. So, but we know we have enough material to make it at least 6.5, or at most 6.5. We cannot go any more than 6.5. Okay, so this is a distributive problem. What is the solution of 3 times t plus 1 minus 4t greater than or equal to negative 5? So my first step is going to be to distribute. 3t plus 3 minus 4t is greater than or equal to negative 5. If you think back to doing this with Mr. Rose and equations, you would at this point probably do circles and squares. So if you want to do that, go ahead. I would first subtract 3 from both sides to get rid of it so that I've got my t's on one side and my non-t terms on the other. So I've got 3t minus 4t is greater than or equal to negative 8. Negative 5 minus 3 is negative 8. So at this point I can combine 3t minus 4t, and I know that that's negative 1t greater than or equal to negative 8. Okay, so at this point I want to divide both sides by negative 1. Think back to that green piece of paper in your notebook. I think it's green. I don't know. It's green in my notebook. But it said up at the top, the golden rule of inequalities. No, it's bright orange in your notebook. the bright orange piece of paper, golden rules of inequality. If I divide both sides by a negative number, I must flip the symbol. And I'm going to spend a minute to explain why. Remember, if I have 1, that's obviously less than 3. But if I multiply both of those by -1, now which one is the lesser value? The -3 is smaller than the -1. -3 is smaller than -1. So I had to flip the inequality symbol. It's the same thing when I divide both sides by a negative number, I've got to flip the inequality symbol. So I have t is less than or equal to -8. Okay, here's one for you to try on your own. Okay, if you look down here, I ended up dividing both sides by a negative. So the golden rule of inequalities told me to flip the inequality symbol. But then there's a problem here. If you think back to the flip-flop paper, we don't want the variable to be over here. We want it over here where the -3 is. So we have to flip-flop the variable and the number. And when we flip-flop them, we've got to flip-flop the symbol. I don't really change anything here. I'm saying that -3 is greater than m, so that means that m is less than or equal to -3. So this is the same thing, and that is my final answer. Okay, here's this one for you to try. Subtract 3n from both sides. So I've got 3n minus 1 is greater than 8. Add 1 to both sides. 3n is greater than 9. Divide both sides by 3, and n is greater than 3. Think if I was graphing this, I would put an open circle on the 3, and I want all of the values that are greater than 3. Okay, when you try this one, this is a little bit tricky. You have 10 minus 8a is greater than, when I distribute, I get 10 minus 8a. If you think back to inequalities, look, these are the exact same thing on both sides. Or you think back to equations. What did we say was our solution if it's the same on both sides? Let's think about it. If I plugged in a 1, I'd get 10 minus 8 is 2. 10 minus 8 is 2. So 2 is greater than or equal to 2. That's true. If I plug in a 2, I get 10 minus 16. That'd be -4 is greater than or equal to -4. So it keeps happening. No matter what value I plug in, it ends up being true because it's the same on both sides. So my solution would be all real numbers. There are infinitely many solutions to this problem. This is called an identity. When it ends up being the same on both sides, it's an identity, and the solution is all real numbers. There is a paper that I have left for you guys to do. It looks like this. We'll go over those problems tomorrow. But it's Solving Linear Equalities Hangman. I want you to show your work on a separate sheet of paper. You will be turning the work in for a grade with the answer across the top of your worksheet. This will go in your notebook, but then you will be turning in your work to me. So please make sure to show your work. And there will be a little quiz over this stuff tomorrow, over everything we've covered up to this point. Have a good day, guys.